Hello everyone and welcome back. We're going to be looking at sets today. A set is just a formal collection of objects. There should be some rule that clearly defines what is in the set and what isn't in the set. So for example, we could have the set of books written by J.K. Rowling. So that would be all the Harry Potter books and anything else that J.K. Rowling has written as well. If something is in a set, we say that it is an element of the set, and we have some special notation. If we want to indicate that X is an element of A, we use this E symbol right here, and if we want to say that X is not in A, then we would just simply cross it out. There are a couple different ways that we can define a set. We could just list everything that is in the set, so the set of states with letters that begin with, whose names begin with the letter V would be Vermont and Virginia. Or we could list it using set builder notation, and this is something that we'll see fairly commonly. We'll say V is the set of all S, such that that vertical line means such that S is a state with first letter V. And then it's still describing the same set. We're still talking about Vermont and Virginia. It's just a different way to write it. We'll use set builder notation if we want to establish that everything in a set has some sort of common relationship, and this is a way for us to highlight that common relationship. There are a couple sets, specific sets, that have specific notation. The empty set, the set with nothing in it, we can denote that by, it looks sort of like a zero with a line through it. That would be the empty set, or you can just write two set brackets and leave them empty. The universal set, this would be all the elements that you're considering. This is denoted by U. So, for example, if you're talking about real numbers, then the real numbers would be your universal set, and the integers would be contained in the real numbers. Let's go ahead and talk about containment, since I already mentioned it. We're going to say that a set A is contained in B if all of the elements of A are also elements of B. So that's very important. It can't be just some of the elements of A. Every single element of A must also be in B. If this is the case, then we would say that A is a subset of B, and we use, it looks sort of like a less than or equal to symbol, except it's rounder instead of pointy. And that means that A is contained in B. And you can think of this sort of as less than or equal to, because if A and B are actually equal, then technically all of the elements of A are also elements of B. And so if two sets are equal, that just means that A would be contained in B and B would be contained in A. And if that's the case, then we must have that A and B are actually the same set. So just keep that in mind. If two sets are equal, they are still technically subsets of each other. Now, if we want to be a little bit stricter with our definition, we have a proper subset. A proper subset is the same definition, so every element of A is an element of B, but we have an additional requirement that A and B are not the same. And in that case, the notation looks kind of like a strict inequality, and so we don't have the little line underneath it, because we are not allowing for the case where A and B are actually equal to each other. So let's look at a couple intervals and see what we can say as far as their set containment. So set A is the interval from 3 to 4. So I'm just going to draw the number line here. And let's see, it looks like we're going to need to go from 2 to 6 overall. So I'll start down here at 1, 2, 3, 4, 5, 6. And we'll add a couple extras. I don't know why that has a line over it. Here we go. Alright, let's see. I'm going to put set A is from 3 to 4. So set A is the interval between 3 and 4. And it is including 3 and 4. And then set B, I'll go ahead and do B in green. B goes from 2 to 6. So 2 all the way over to 6. And I'll shift A down a little bit so we can see it some more. There we go. Alright, so let's see. And just for reference, A was yellow and B was green. Alright. Let's see. Well, looking at these two intervals, I can see that every element of A is also inside of B. So we can say that A is a subset of B, I can also see that A and B are not equal to each other, so we could get a little bit more specific and say that A is a proper subset of B. This would be true. We can't go the other way though, right? B is not a subset of A, so we could indicate that by crossing out the subset. So B is not a subset of A because B is much bigger, right? And so every element of B is not also an element of A. Some of the elements of B, specifically anything in the interval from 3 to 4, is also an element of A, but we can't say that for every single element of B. They're not also an element of A. All right? And let's look at one more example before we end this. Let's look at sets defined just by listing. We want to know if the following statements are true or false. So we have A, which is the set 1, 3, 5, 7, 9. And the question is A a subset of B? Well, right away we can see that this will definitely have to be false, because A is much bigger than B, right? So there's no way that every element of A could be an element of B. A has more elements to begin with. They share one element in common, the 5, but they do not share every element. So question 1 would be false. Question 2, is B a proper subset of A? Notice the notation is a little bit different, and so this is asking about a proper subset. And so that means that every element of B is in A, and B and A are not the same. Well, let's see. Every element of B is the 5, and the 5 is in A, so B is definitely a subset. We can also see that B and A are not the same, so B is a proper subset. So this would be true. Now let's see. What about set C? Is this a subset of A? So C is over here, and we have 1. So we need to check, is every element of C also an element of A? So 1 and 1. 1 is in C and 1 is in A. What about the 2? 2 is in C. There's no 2 in A. So this is going to be false. Some of the elements of C are also in A, but not all of them. So we do not have a subset. What about the other direction? So B, a subset of C. So now we need to check, is every element of B in C? So B is a 5, and we have a 5 right here in C. So every element of B is in C. So this would be true. And now we need to know, is A proper subset of A? So notice the notation, right? This one is also a proper subset. So we're checking two things. Is A contained in A? And is A not equal to A? Those are the two requirements. Well, A is a subset of itself. Every element of A is in A. So we get the first requirement, but we're not going to get the second one. A not equal to A, that's false. So we end up with a false statement for 5. And that's something in general, a set cannot be a proper subset of itself because they would be equal to each other. Alright, that's all for now. When we come back, we'll be looking at complements.